All right, next one, absolute value. So y equals the absolute value of x. What's that look like? A v, right? Okay.
Isaac Fitton, please report to the secondary office. Isaac Fitton, please report to the secondary office.
Yeah, what weird order are you doing this?
Okay. Just the order off of this. Oh well. Y equals the absolute value of x. V-shaped graph. Why is it a V-shaped graph?
Because it's always positive.
Absolute value always represents a distance from zero on a number line, making it always positive, so therefore your y values will always be a positive amount. Okay? When your x value is -3, your y value is +3, because -3 is a +3 units away from zero on a number line. Okay? So that is why it has the shape that it does. It is basically a linear function. On one side the slope is 1, on the other side the slope is -1. Okay? Domain, what numbers can you plug in for x and expect to get an answer? Everything, negative infinity to positive infinity. Okay? Alec, what's our range?
Zero to positive.
0 to positive infinity. 0 with a parentheses or a bracket? Parentheses or bracket on the 0?
Bracket.
Because?
Because it touches the...
Because it touches 0 or hits 0, right?
Good job.
Okay? Domain range. Domain range and why it has that shape a little bit. Okay? Going through these pretty fast. Stop me if I need to slow down for anything. If you have questions, please ask. Okay, next one I got on here is square root. Square root, whatever. Okay?
I think he's very funny.
Alec, give me some coordinates.
Oh, let's go, Alex.
Oh, 1, 1.
Good job. Keep going.
0, 0.
Good job. One more.
4, 2.
Wow. Good job. Okay. All right. 0, 0, 1, 1, 4, 2. Graph looks like kind of half of a sideways parabola. Okay. Half of a sideways parabola. Y equals the square root of x. Domain. What numbers can you plug in for x and expect to get an answer? 0 to infinity. Why can you not plug in negative numbers for x?
Because then we have an imaginary number.
So you get imaginary answers. You won't get a real answer. You can't do a square root of negative numbers. Okay? So domain is 0 to infinity. And the range ends up being
0 to infinity.
0 to infinity because your answers you will get. Your y values that you will get. Your y value, the lowest y value you ever get is 0. And all the other y values keep getting bigger and bigger and bigger. So from 0 all the way up to infinity. Okay? Domain range. That one alright? Okay? Exponential. Y equals e to the x power. Y equals e to the x power. There is really only one coordinate that we will be really concerned with when it comes to your drawing of this graph. What is that coordinate going to be? 0, 1. If you plug in a 0 for x, you will get 1 for y because e raised to the 0th power, any number raised to the 0th power except 0 itself is always equal to 1. Remember, e is like 2.731 or something like that. Okay? A little smaller than 3. So really you just need this point 0, 1 right there. Then just do your best to kind of draw a nice exponential growth. Make sure it does not go below your x-axis here, so the graph's gonna look something like this. Okay? As an exponential function, that's an example of exponential growth. Okay? What numbers can you plug in for x and expect to get an answer for y? Anything, right? Negative infinity to positive infinity. You can plug in any number you want to for x and you'll get an answer. You can take e raised to a negative 1,000, e to a positive, you'll get an answer. Okay? So you can plug in any number you want to for x. This graph goes forever, left and right. So your domain, negative infinity to positive infinity. Okay? Range, the answers that you get, the y values that you get after you plug in any of those numbers for x. The y values that you get will be what?
Close to 0 and infinity.
From close to 0 to infinity, but it never actually equals 0. It gets really, really, really close to 0. If you take e to a negative 1,000 power, that would be like 1 over e to the 1,000 power. So really you have 1 over this ginormous number. Okay? That's a tiny number, but it's still bigger than 0. Okay? So yeah, on your calculator, it would eventually give you 0, but officially it is not. So that's why we will do a parentheses 0, comma, and it goes up forever. Okay? So there's your domain and range. Okay? The inverse of exponential functions, like this, are logarithmic functions. Okay? And that one specifically will be y equals the natural log of x. Stop me if I get close to 15.
You're good now.
If this is the inverse function, this is one that isn't always necessarily easy for some people to figure out, okay? But if this is the inverse function of that previous one, of that exponential function we did, yep. So the coordinate on that previous graph that I said you had to make sure your graph went through was 0, 1. So that means on this one, when you go to graph it, make sure it's passing through the point 1, 0. Okay? And then this one ends up looking like this. It's got to hit the point 1, 0. Also, because it's an inverse function of that previous, the domain and the range of that exponential function flip to give you the domain and the range of this one. My domain will be not at 0, but just above 0 to infinity. Okay? And my range goes from negative infinity up to positive infinity. Don't cross the y-axis on that. Okay? Questions on that one? Sine curve, cosine curve. Hopefully we have these down.
I don't.
Where does the sine curve start?
0.
The origin. Okay.
Bryce, you are bad.
When does it get up to 1?
At pi over 2.
Pi over 2.
Come on, that was your ridiculous.
Pi over 2. Pi. 3 pi over 2,
Are you talking?
2 pi.
You guys are in for quite a surprise. I'm surprised right now. Just wait till she comes
Wait,
up.
never mind.
Yep.
Okay.
7, 8.
Probably just one period will be enough when it comes to you guys graphing it. So sine curve starts at the origin. At pi over 2, it's up at 1. At pi, it's back to 0, and so on. Okay? 3 pi over 2, it's at negative 1. 2 pi, it's back to 0. Completed one full cycle, one period. Okay? Cosine x, where does it start?
1.
Up at 1, so 0, 1. That's pi over 2 there, so.
Hey, you're okay. Thanks. You're okay.
Domains and ranges.
Negative
What numbers can you
infinity,
plug in for x?
infinity to positive.
Okay, domains are negative infinity to positive infinity. You can plug in any number you want to for x. But my y values,
Negative 1 to 1.
negative 1 to 1, brackets, parentheses.
Brackets.
Brackets because it hits negative 1 and hits positive 1 and everything in between. So domain, negative infinity to positive infinity, range, negative 1, positive 1. Okay?
I got you, bro.
Reciprocal? Reciprocal function, y equals 1 over x. Okay, y equals 1 over x. This one's a little bit different. It has a vertical asymptote on it. Where does that vertical asymptote occur?
0.
At 0, because you cannot plug in 0 for x and expect to get an answer for y. 1 divided by 0 is undefined. Therefore, you have a vertical asymptote right here along the y-axis. Okay? Really, your specific coordinates, 1, 1, negative 1, negative 1, and then draw the approximate shape of the graph. The values, as you plug in larger and larger and larger numbers for x, your values will approach 0 but never actually reach there. So actually there is a horizontal asymptote on this one as well at y equals 0. Okay? I don't know that. I don't know what will make you draw that. I guess won't hurt if you do. There is a horizontal asymptote on this as well.
How do you write that?
Domain and range.
Do you want me to just stop this
Are
one?
you at 15?
It's at 14.
Exactly 14.
Yeah, well, 1403,
I
1404.
can get it done.
All right.
Domains. Domains. What numbers can you plug in for x? Everything except 0. So therefore your domain goes from negative infinity to 0 and then picks up again from 0 until positive infinity. Okay, so that's a union. It's like saying and. So negative infinity to 0 and then from 0 to positive infinity is your domain. And if you look carefully, your range will be exactly the same thing because it hits every y value except 0. So that is also your range. Go ahead and stop me if I